Hi, in this video, I'm going to demo a full-stack TypeScript monorepo showcasing modern development practices. This is a monorepo with a NestJS API and a React Vite frontend. So NestJS is a progressive Node.js framework for building efficient, scalable server-side applications using TypeScript. It's very opinionated, so it has concepts for dependency injection, data transfer objects, services, controllers. I'll get more into that stuff later. And in this monorepo, we're going to manage everything with Turborepo and pnpm. And the key thing about this approach is it's fully type safe end-to-end. So we have a Drizzle database at the back end. So we have a database, we have Drizzle schema, then we have DTO services and controllers. This is used to create a Swagger Open API contract, and this is consumed by a tool called Orval, which is going to generate front-end code, so the generated client and React query hooks that can then be used in our components. So this is really aimed at giving the best developer experience by full stack end-to-end type safety. I'm going to start by introducing the repository, and then I'll show how the project is structured. After that, we'll walk through 2 tickets to demonstrate full stack development in this setup. So introducing this repository, as I mentioned already, this is a full stack TypeScript monorepo. And if we go over to the code, we have 2 main apps. We have the API and we have the web. The API has the NestJS project and the web has the React code. If we go to the README, we can see some more information about the general setup. So the tech stack for the backend is NestJS, Drizzle, exports Swagger, and uses Vitest for testing, and there's a class validator for validating responses. On the front end, we have Vite, React, Orval, which I mentioned, TanStack query for fetching data, and MSW, which is doing API mocking for tests. And for the overall management, we have Turborepo to manage the monorepo packages and pnpm to manage the installs. So to get started, after checking out the repository, you just need to pnpm install. Make sure your environment is set up. So if you just follow the env.example in the API, you basically just need to specify a database URL, which will be a file where the Drizzle SQLite database will be saved. And then we just need to cd into the API app and run these database generate scripts. So this will generate a migration for the database, and then pnpm db push will create the database. And you can see we have this file here, db.sqlite. So now if I go back to the project root and run pnpm dev, then we see we have our app running on localhost 3000, and the NestJS application is running too. I can open it up and I see my application. I can add a user here. We'll just say build blogs. I get an error here because there is no user by ID 1. So basically we have a few queries here. The first one is showing all users. The second one is showing user by ID. And then down here, we have a mutation to add a new user, like so. And you can see that when we add, it refetches. So that's the front end. I can, on localhost 3001, I can show the Swagger documentation. So here we have our users endpoint, the default hello world endpoint. And if I want to post new users, I can try it out here as well and execute. So you can see that it's added John Doe to our application. If I refresh, then John Doe is here now too. So that's a quick demo of the application from the front end. And the key thing to note about this setup, as I mentioned, is the end-to-end type safety. So if I take something, if I go to the schema, so this is now my Drizzle schema, and we see we have this property name. This property name is actually being used in the DTO, is a data transfer object. You can see that here it's referencing name. And then this name here is actually being pulled into the front end. So this DTO creates a JSON Open API schema. So we can see here in my user details DTO, I have this type, and then this is actually pulled into the front end. So if I go to, for example, my users list, then we can see that we have here fetching from this query which is auto-generated and it's type safe. So what I mean by that is I go here, I say name, then I can see all the properties that exist. I can't do something like this because it will say foo does not exist on user details DTO. So that's a very brief introduction to the tech stack for this monorepo. Let's have a look at a couple of tickets and how you would implement them, and we can show what it's like to actually work in this full stack application. So let's have a look at our first ticket. So imagine this ticket comes in. We want to refactor the user data model to separate first name and last name. The first name and last name is now a single field, and we want to split it into 2 fields. So for the changes, we have to update the database, we have to refactor the DTOs, we have to update the endpoints, change the front end components, and fix any tests that will then fail from that change. So in order to do that, let's go over starting at the schema. So if I start with my schema here, then you'll see here I have my Drizzle. So Drizzle is a ORM for managing databases. It's quite a new modern one, which is quite popular right now. So we have here our name field. And if I want to, let's start by changing name to be called firstName. And we can see that as soon as we save that, we immediately get type errors, right? So the first type error we get is in the DTO. So it says, hey, now this doesn't exist anymore. So when we do that, it's going to fix the problem. So this here is exactly the same as doing this. You could just say string. When we reference like this, we're just saying user row. So the type of the insert, which is the this type is created for you by Drizzle when you create tables using the create table helper. So it gives you this type. And basically we could, everywhere here, just write the type directly. So here we have our DTO, data transfer object for our users. And if we wanted, we could just put string here. But by referencing through this generated type, we're creating a strict link between the data transfer object and the schema, which means that when we change the name, change the property, then we get type errors, which is what we want with this end-to-end type safety. So I've added this first name. I'm now going to add last name. So we say text not null. And then again, we can go back to the DTO. So now, for example, here, so we have these annotations to tell Nest, that this is an API property and validations and stuff. And we come down here, we can just go here and change this to last name. And again, reference like that. And there we go. So we have more type errors. If we come down here, we see that we have this create user DTO. So this is the data transfer object, which is used for creating users. And what we can use is this NestJS useful utility type, which is essentially just like a pick for the base. So this is quite a nice pattern for doing things. We define everything we want on the base DTO, and then we can create other DTOs from it by just selecting which properties we want. So here for this one, we just want to have first name and last name, and that's now updated. Now, if we go, we have a mapping function, which is going to map from our row class into our data transfer object. So this is the one which is used for mapping from the data coming back from the user table into the user details DTO. So there's a type error here. This is just showing how you can add more properties. So for now, let's just make this the capitalized first name, and that's now going to fix the problem. So by the way, this is quite a nice way of doing mapping. We basically have this map to DTO function, which is going to use the class validator to validate and also pass the type, removing any additional properties that aren't exposed. So here's an example where you see we have an additional property here, and this will just be stripped out by Nest because it's not included explicitly in this DTO. And in order to explicitly include properties in the DTO, you have to use this expose. So this is what means that it will actually be returned. If you don't expose properties, it won't send them. So that's useful if you have some sensitive data on your row object, which you don't want to expose over the front end. That's a useful way of doing this. So there we go. We fixed more type errors. Let's go to the next one. So now we have the user service. This is the create function. And you can see that again, we have a type error. Actually here, instead of mapping explicitly here, we can just take this object and go straight into the data. So we just go, by doing that, we won't get type errors here again, because we basically just forward the type of the create user DTO into our repository saying insert into this. And again, that is type safe because this is going to expect that table row. That's going to expect that table row type, which is defined in the schema. So now we fixed all the type errors, but if we actually go and load the front end, we'll get an error, and it will come through to the back end because we need to run a migration on our database. So you can see we have an error from SQLite. So in order to fix that, we need to rerun the migration. So I will cd into apps API and just run. Let's go back to the README. We can see that we have to run pnpm db generate. So it's going to say, hey, we're going to change name to first name. Okay. And then we're going to add the last name column. Okay. After running the migration, we then need to push those changes to the database. So pnpm db push. And then it's going to warn me saying, I'm going to truncate one table because your schema has changed. It's going to actually recreate the table. So we'll end up with no users. If I run that, then we can see now if I try to create a user here, then the next thing to do is refactor on the front end, because now if I try to do this here, we'll get a 400 saying that property name should exist, etc. Right? So now there's an error on the front end when we try to add users. But just to demo, we can add a user from the back end to show the completeness of this. So again, I'm going to add John Doe, so you can see that it's changed the API properties here. And if I refresh, then we can see that we have some data, but not all data on the front end, because again, this is the types now need to be pulled into the front end. So basically, we've done everything at the top. The Swagger Open API contract has been generated, but now we need to use Orval to actually generate the client code and update it. So in order to do that, what we can do is cd into the web app and run this script here, npm generate API. And what that's actually going to do is it's going to rerun the generator, and you can see that we have some front-end code being regenerated. So what Orval does is it generates you a type-safe query client to use with the React query that you can then use in your components. And then you can create that using this generate API script. And the way that's set up is actually on the back end, we have this Swagger JSON schema. So if we go here, this is the normal Swagger UI. And if we go /JSON, then we can see that this is actually the API schema. The way that is set up is if we go to the main file in the backend, then you can see that we create this JSON schema document and we host the UI on /Swagger, and then we host the JSON document on Swagger /JSON. So then in our Orval configuration, we just have to say, we're going to use this JSON schema and then provide some configuration for what we want. So we say, hey, we're going to use React Query. We want to create MSW mock responses. And also you can specify some custom overrides here. So here we're saying that for constructing the API calling instance, we're going to use this custom mutator.ts file. So this is where we actually do the fetch. So you can see that we're doing a fetch on localhost 3001. And here you could put anything else if you want to inject authentication headers or whatever. Then this is where you basically add your custom logic to the generated files that Orval is going to create for you. So now we have this, we can cd into apps web and run pnpm generate API, and it's going to generate that front-end code using this Orval specification. So now that we have reran the generator script, we can see that we have errors now propagated into our front end. So we just need to go and fix those. So we'll ignore the tests for now. Let's just fix the issues in the components. So if I go to my add user component, then we can see that when we try and add a user, instead of having name, we now need to have first name. So let's create a property for that. So what I'll do is I will refactor this to be called first name, and refactor this to be called firstName. Yeah. And then here, when we pass the data in, instead of passing in name, we have to pass in firstName. We then need to have, you see here that we still have an error because it says, hey, the create user DTO is actually expecting firstName and lastName. LastName is missing. So what we can do is add a lastName here, and we'll just add a UI to specify that. There we go. So placeholder here should be firstName. And then here, we just pass in firstName and lastName. And by doing this, we have fixed all the errors in this component. Let's go over to the other component and fix any other type errors that we have. So we can see that in our users list, again, we have errors because it's now no longer name, it's firstName, lastName. So we'll do this, firstName and lastName. Cool. So let's see. Now we only have the errors in the test, which means that the front end should work again. So I can refresh the page. Oh, okay. So yeah, I can ignore this error for now because it's just an error in the test. And if I now come in here and I say, I don't know, Bill logs, and I add that person, then we can see that here we have the user. So we no longer have a user with ID 1 because we truncated the table. The new ordering starts from 4. So what I can do to just show that the get user by ID is still working is come into here and go into the main app. We have this user by ID, and we'll just change this to 4. And let's check if we have any type errors here. No, we don't, because we only show the created app for this user. So user by ID, ID is 4. Okay. And we can see, yeah, we have just the creation date for the user by ID. I'm actually going to add the other data here as well. We have data firstName and lastName, just to show that, again, we have the type safety here coming from the find one query. So here we go, user by ID, and we show this should say, so user by ID 4. So really this shouldn't have to duplicate this number here, but for now it's fine. So we have user by ID 4, and then we have the details there. So all the queries and mutations have been updated. Now we just need to fix the test. So again, we have this TypeScript error, typesafe error in here. And you can see that it's already made a suggestion here to update the test on the front end. So seeing as we just updated that here, let's actually run the tests on the front end and see if it works. So we can do pnpm test. So we can see that we got a failure. What I'm going to do is I'll just tell cursor to fix it, and we'll see what it does. Fix the front end tests. Okay, now all the tests are passing, and let's check. Okay, cool. Let's see what it changed. Basically, it's changed the add user test to set firstName and lastName, and then it's basically passing in all of the new inputs for firstName, lastName, and then expecting that the display value is also firstName and lastName and not just the name field. So yep, that's now done on the front end, and let's also update the backend test to make those work too. So I'm going to stage this change, but I would imagine that we now have errors on the backend. So if I go into my backend and I do type check, we can see that I actually have errors in my end-to-end tests, again, because of this type safety. So for example, if I look up this test, then you can see that again, because we've refactored this DTO, now name needs to be split into 2 fields. So again, I'm going to just tell cursor to fix this, and I'm going to say fix the backend E2E and unit tests. So a good time to mention, on the back end, we have two different types of tests. We have the unit tests, which test the controller and don't actually save anything to the database. They just basically verify that the service is being called correctly. And then we also have end-to-end tests, which actually mock the database, create a test SQLite database, and then really send HTTP requests to actually verify that the data is being saved or fetched or whatever from the database. So now we can see that cursor has actually come in here and fixed everything we need. So it's made this assumption here for capitalized name that it's now changed it to first name and last name, whereas, okay, that's fine. Before we just said first name. I think it doesn't really matter. This is just a demo of how you can like basically create a new property on your DTOs. And now in our unit test, you can see that it's split the name into first name, last name, just doing that change. And then for the controller, we've again done the same change. So split into first name, last name. And we assert that when we fetch from, for example, when we create using post users, that we get those properties back. So split first name, last name. So let's do one final check. Let's run pnpm test on the backend. And let's also do test e2. Great, the tests work. And let's test the front end one more time as well. Great. So that's actually now the first ticket done. And we should see that if I refresh the front end, we don't have any more errors and everything works fine. Good, everything's working great. So let's add a commit, make sure everything is staged. So add a commit, done, ticket 1. Okay, so that's done. Let's now have a look at the second ticket, which we want to integrate, which is a little bit more complex than the last one. So for this ticket, we want to implement a search endpoint, which will find users by first name and or last name and do that on a matching basis. So if you search, for example, for B for first name, then in this case, you would get basically user number 5 and user number 6 because their first name contains the letter B. And so we want to have a new API endpoint. We're going to do get. We're just going to search by first name and last name. And we want a new DTO, and it's only going to return first name, last name, and also full name. So we don't want to return any other properties. And we're going to create a search component for the UI to actually search that. And then, of course, update any tests and add end-to-end tests, unit tests, front-end tests. So let's start, as you always should, by updating the API first so that you'll get the contract, and then you can do the front end after the API is already exposing what the contract for that new endpoint is. So I'm just going to go to cursor and I'm going to tell it to do it for me. So I want a new route for find names, which receives a first name and last name and filters the user by string contains. It returns a DTO user name details, which has first name, last name, and full name. Okay, so let's give that to cursor and see what it does. Okay, so cursor's done it. It took about a minute, and let's see the changes that it's made. So let's start out with the controller. So we can see that it's added this new find names function, and it returns this user name details DTO, and it also calls the find name service. So let's start by seeing what so let's just say keep all of the changes, and let's have a look. We have the find names function. So this is using Drizzle, a query builder, to actually write a contains a query saying, hey, it needs to either contain part of the first name or the last name and then return the results. So that's the query. And then we have the mapper function and the new DTO. So this to user name details DTO takes the response from reading the table and passes it into this new DTO, which has been created. The new DTO here contains first name, last name, and full name. And that way, we basically then in the mapping here say first name, last name, full name, and any additional properties which are on this row will actually be stripped out. So we don't have to manually strip out the creation date, ID, etc. Because as long as they don't exist in this DTO, they will be stripped out. By the way, that is actually done by, you specify that somewhere in your application. So how you want to behave when those things are missing. So we have this class serializer interceptor, and basically it strips out properties that are not exposed over the target class. That's for responses. And then we also, for requests, have a validation pipe, which means if you try to send additional properties that are not expected by the request, it will actually throw a 400 error. So that's a global configuration. You can overwrite it per route if you want to, or you can just set it as the default behavior across your entire Nest API. So we have this mapping, and let's see, does it actually work? If we go to our new and go to our Swagger, we have this new find names thing. And for example, I can try it out and I can search for B on the first name, do a search, and you can see that we get back Bill and Bob. If I search for BI, then I only get back Bill. So that worked. There's one kind of slight improvement we can make here though, which is just make things a little bit cleaner and a little bit more dry. Do not repeat yourself. If we go over to the DTO, on the user DTO, so you can see that it's actually copy pasted everything across. What we can actually do is, instead of copy pasting, we can use these nest utility types again. So what we're going to do is we're going to say for this one, we're going to, because we already have first name and last name defined. So for the user name details, DTO, instead of defining them again, we can just say extends pick type, and then just pick the ones we want. So by doing that, we are not, repeating those properties because we can just take them from the base DTO. And then also for the query, we can do a similar improvement. So rather than having to replicate them, we can again just do this like that. And now if we go to the API, then we can see that it's not quite what we want, because now we have to specify both. So for example, if I do want to search for just B, then again, actually Swagger won't let me do the request, but if I wanted to do it anyway, then I would get a 400 error saying that you're not allowed to do that. Maybe I can just show it in cursor quickly. So if I do, this is a curl request, and if I actually deliberately try to curl the API, and I say, I'm going to deliberately not specify a last name like that, then you can see that I actually get a status code 400, because it's saying that we have on our pick type for our base DTO, we said that that the first name needs to be a string with a minimum length 1, and the last name needs to be a string minimum length 1. So yeah, in order to fix that, we can actually use another utility type, which is quite useful, called, I think it's called partial type, if I remember correctly. Yeah, we can inherit that from Nest. And what that'll do is it's just like the partial utility type for TypeScript. It will make everything optional. So it will overwrite the validation and make them all optional. So now we have what we wanted again. So if I try it out and I search for B, then you can see that I get my responses. So this partial type is basically saying make everything optional. And then, yeah, this is just nice because it means that if you come in later and you want to change, for example, any of the validation on this stuff, you only have to change it in one place. You don't have to change it across all your DTOs. So this is just a little bit of a nicer way to do that. By the way, let's talk quickly about this expose property. So you'll see with this expose that basically everything in this setup has to be explicitly exposed to be available on the API. So for example, if I decide not to expose ID, then you can see that if I, for example, search my users, which normally would return the ID, and I execute it, then you can see now that the ID is actually not being returned because we decided not to expose ID anymore. So basically, if you're adding stuff on the DTO, you in this way of setting things up, you have to explicitly expose, which means I want to send this over the API with all of your responses. Okay, so that's done. I think my cursor did actually update the tests as well, but let's run them again to make sure they work. So pnpm test. Let's just run it on the API. So cd into API and run pnpm test. Okay, yep, all the tests pass, and test E2. Yeah, good, all the tests are still passing. Let's see, I think in here, did we add a new test for E2E? Yeah, it did. So it's added a unit test, sorry. It's added a unit test for our new find names. And you can see that it was able to work out how to do this. So passing in and then asserting that the service is being called correctly, should return the filtered users. Okay, great. So, and then we also have here the end-to-end test, which Cursor already just went ahead and wrote for the find names function. So you can see that it starts out by inserting some names into the database and then does a search to see can it actually find them. and expects those responses to exist in the returned HTTP response. So great, the entire backend side of this second ticket is done. Let's now go and implement the front end. So the first step, just like before, when we integrate the front end, is to actually regenerate the front end code. So going back to our diagram, remember that we're using this Orval package to actually generate client code, which we can then use on the front end. So in order to do that, I'm going to cd into apps web and run the script, which is listed here, pnpm generate API. So if we look at what was generated here, we have the types, which are coming from the backend. So this new user names detail, DTO. We also have these new React query hooks, which can be used to fetch the data. And another thing that Orval gives you, which is nice, is it gives you these MSW, stands for mock service worker mock responses, which can actually be used in the tests. So it means that you don't have to manually create mocks for all of your service responses. So if I can show that here quickly, just like in the first diagram where we see that we use Orval to create the client, and that can be used with React Query with the components, it's actually also going to create mock service handlers, which can be used to, they use Faker.js to create fake data, and that can again be used with the React Query to write your component tests. So while there are a lot of packages that will actually create client code from a OpenAPI contract, I like Orval because not only does it create the types and the SDK, it also creates the React query hooks and the mock service worker functions to help with mocking your API. So now let's continue. We have the client code generated, and let's give Cursor an instruction to actually use it. So let's open up a chat and let's say, give me a UI for searching usernames using the new find names endpoint. Okay, so here are the changes. Let's see if it worked. Okay, cool. I have this new component down here. I can search for B, and we can see that, yeah, I get my Bill blogs, Bob blogs, so it's working. So let's review the changes that Cursor made here. So the first thing is I like to do, which Cursor has copied my pattern here, is just re-export the hooks and the utility functions, which are created by Orval, which is nice so that it gives me a nice way to use them. And also just there's one point where the integration is happening. If this hook changes, then you only change it here, not entirely across your application. So you can see where this is now used. So we have the data saying api.users.findNames and then passing in the query parameters. Again, this data here should be fully type safe. So for example, if I can see where it's being used, then inside each of these users, it's a user name details DTO, and you can see that we have first name, last name. So for example, if I wanted to use my computed field full name instead, then it will be here, user.fullname. So here we go. Okay, great. And there's one more thing, which is kind of a bonus feature, quite useful, which Orval gives you, which I haven't seen coming from many other packages that generate the front-end code, is let's say that we are searching for Fred and there are no matches found, but we actually add Fred now, and let's call Fred Smith, right? And when you add, then of course it doesn't refresh the search. But if I do, for example, this, then again, it still doesn't refresh. But if I search Fred here, then we get the response. So if you actually want to, you might want to say when we add a new user, we want to invalidate all of the searches so that it will fetch new data. So in order to do that, then we again get these nice utility functions. So if I go to add user, you can see that already whenever we add a user, we're going to invalidate queries. So this was created for me by Orval, which is really nice because usually if you don't have that, then you end up managing all these cache keys yourself. It gets a bit messy. You end up with like a bunch of strings that you have to manage. So if I want to invalidate queries here, then we can see that I can also invalidate API users.findNames. And what that will do is just any cached data for this query, which is finding names, will also be cleared. So let's test this again. Let's search for Ben Smith, right? So there are no matches found. And then if I add Ben Smith, then as soon as I add, you can see that actually it already finds because I invalidated the search as soon as we added. So it's really nice having these automatically generated query keys as well. It keeps everything very nice and simple, and it's much nicer when you want to change things around, refactor. You don't have all these untyped strings that you're dealing with. Okay, great. So that's the front end side of the code done. Let's just write a simple test to demonstrate how to integrate the front end tests. So I'm going to use this prompt here, add a front end test for the new search feature, and keep it simple, add one simple test only. Okay, great. So the test has been added. Let's see what it's done. So we have this new test for the search users component. We have a mock user. So again, we can use the DTO here, which is being imported from the Swagger API spec. And this is what I mean with the reusable MSW hooks. So what we do here is we just say, hey, I want to mock this response, and I'm going to specify this data, which should be used for returning. And then when we actually do a search for John, we verify that we got John Doe back in the response. So if I run this test, pnpm test, then you can see that all the tests pass. And the thing that is really nice about using these mock service workers is I just realized we don't actually have a test for searching users. So let's fix that. Let's say add a front end test for user list. And if we open this up, we can see that by default, Cursor has actually created some mock users here, but we actually don't need to do that because Faker will generate them for us as long as we don't really care about what the actual results are, because they're just going to be faked by Faker. So what I can do here is, instead of actually specifying let's clean this up. Yeah. So now if I run the test again, you'll see that it does actually fail because it's not going to be John Doe, Jane Doe anymore. But I'm going to tell Cursor, like, update the test to work with the auto gen Faker response. And what that's going to do is, just rather than actually hard coding the mock responses, Faker is already going to return some, and then it's just going to verify that some data is being displayed on the screen and not exactly asserting what it needs to be. So in order to actually test this, you probably shouldn't do this. It's better to be explicit. But just by having those mock responses, it means that if you are testing something else for a component, you don't have to worry about mocking every response, because the mock service worker, the generated mock service worker, is already going to give mock responses for all your APIs. So you could just focus on testing what you want to, rather than having to make sure that your test mocks everything it needs. You can only have to mock exactly what you want to do for that test, and everything surrounding, like if it's going to fetch more data from other routes, that's all just going to be mocked, and then you can just focus on testing what you actually want to. So I'm just going to revert that example, run the tests again. And yeah, okay, everything passed. And now I will add another commit, and we'll say implemented ticket 2. And there's actually one more thing you can do, which might give you a better developer experience depending on how you want to work. So recall that throughout this demo, whenever I change the backend API schema, I've been manually running the generate API script to pull those changes into the front end. So for example, if I remove this property here, full name, and then save, then I actually have to cd into apps API web and just run the generate script. And then by doing so, that's what's actually going to pull the changes using my JSON schema. So it's going to create a new JSON schema. You can see updated, and then it's going to create new front-end code based on that schema. So this is a totally fine way of working. Maybe you say, I want to do everything on the back end first, and then I'll worry about fixing the front-end changes. But you may say that I want it, every time I make a change to the open API schema, I want to automatically regenerate for the front end. So that's possible. So what you can do is, I'll just show my changes here. So now what I've done is I have in the main.ts, as well as hosting the OpenAPI JSON on the same endpoint, Swagger/JSON, I actually also create it as a local file and just save it to the /out directory. The out directory is actually ignored in my git ignore as well, because this is only used for development. We don't need to stage that. And also in main, this only happens when we are not in production mode. So in production, we don't need to save this file. When we are developing locally, we're going to save that file. So that file is now saved locally. Every time we change the OpenAPI schema, or every time we change our DTOs or whatever, the JSON is going to change. It's going to be saved, updated locally. And then in our Orval configuration, rather than referencing localhost 3000 swag.json, we say we're going to generate it from that local file which we created, which is going to be go up one directory /API/out OpenAPI.json. So now we're generating from there instead. And then the final thing I did is I added this plugin for Vite, which is a custom plugin which I wrote, which basically says, look at this file, which is going to be OpenAPI.json, work out if it changed. So we use a hash to work out if the file actually changed. This is the most efficient way of doing this, because the file will now be recreated every time we make a change on the backend, but we're only interested in if the JSON file, the JSON schema actually changed. So now we're saying, hey, if this file changed, we want to rerun the generate script. So we import generate from Orval and we specify the configuration, same as before. So what that now means is that if I pnpm dev, and then finally, one more thing is we actually need to use that plugin in the Vite configuration. So by saying this, we're saying only in dev mode, we want to add this plugin to regenerate the front-end code every time the schema changes. So now if I pnpm dev, then we can see that it should be everything running normally. Yeah, cool. But what happens now is if I go to, for example, my DTO again, and I deliberately remove this property and I save, then we can see that it flashes up here. Automatically, it came up saying your OpenAPI spec has converted, ready for Orval. I didn't have to manually run the script. And then we can immediately see that we get those TypeScript errors in our front end. We didn't have to manually regenerate ourselves, because my new plugin has seen that the OpenAPI schema JSON file has changed and just automatically regenerated the front end code. If I comment this field back in again and save, then we'll see that it's going to regenerate the client code again, and all those type errors are gone. So yeah, if you prefer working this way, where as soon as you make a change on the back end, you see it reflected in the generated front end code, then you can use this. If you prefer to manually generate the front end code every time you make a backend change and work in that way, then you can. Both ways of working are totally valid. So in summary, we have successfully added search functionality end to end. Everything is type safe from the database to the front end. We have comprehensive test coverage for backend and front end. The monorepo structure makes it easy to work across the entire stack, and Orval keeps our API client in sync automatically, along with MSW, mock service worker, makes front-end testing easy without needing the real backend. Key takeaways: type-safe development across the stack, monorepo benefits for full-stack development, automated API client generation, comprehensive testing at all levels, and clean DTO patterns with NestJS helpers.